the biggest problem is the tooling, micro tooling. When you have core pins really the size of a hair, or cavities in a mold that you can't see unless you have a microscope, you're 85% of the way there when you have a good tool. When you have a good tool, a good engineered design tool. Because even those hair-sized components still need to last for the full depreciation value of the tool, which is 5 to 7 years. So hair-sized components lasting a long period of time is a difficult challenge. So that is the most, in terms of micro-molding, which is one facet of manufacturing, that is the most difficult. Because you have, in steel, you don't have a lot of shrinkage with material. In polymeric materials, with larger parts, typically if they get injected, they shrink over a big, large area. But micro-molded components, relatively speaking, they don't shrink because what you have in steel is what you have in plastic primarily. So that's why it's really important for the steel to be very accurate, because you can't rely on shrinkage to bring it in. Then there's, the measurement. That's a challenge. That's always something that I hear in the industry is, okay, yeah, I made the part, now how do I measure it? Because if you can't make it, if you can't measure it, is a theme in micro-manufacturing, because you have to validate that what you've got out of the mold is accurate. And the only way to do that is to measure it after you've made it, in a lot of cases. So that's another facet of what's difficult about micro-molding. There's several challenges, but assembling them, now you pick up this teeny tiny microscopic piece of dust and have to assemble it to something else. That becomes a challenge. So what you try to do is marry all of those pieces together in an assembly within the mold itself, so that you don't have to worry about secondary operations and putting those pieces together later on.